मैम आप कैसी हैं?
मैं ठीक हूँ बिल्कुल। ठंड बहुत हो रही है आज।
हाँ, ठंड बहुत ज्यादा है। जस्ट टेक केयर। नितिन भाई, गुड आफ्टरनून।
गुड आफ्टरनून सर, क्या हाल?
बहुत बढ़िया सर, आप बताइए कैसे हैं?
ऑल वेल सर, ऑल वेल, ऑल गुड है। बोस मैम से मेरी आज पहली इंटरेक्शन है। हालांकि कई बार हम लोग हाँ, हालांकि मैम हम लोग कई बार मिले हैं आगे पीछे, चाहे देहरादून के काम रहे, चाहे डीडीएफ के साथ हम लोग कंपटीशन में रहे, बट हम लोग मिलते रहे, आपके बारे में सुनते रहे। मेरी आपकी मुलाकात आज पहली बार है।
ओके ओके, वाकई में मैंने भी आपका नाम बहुत सुना है और सब लोग आपकी बहुत तारीफ करते हैं।
मैम ये आपका, मैम योर ब्लेसिंग्स, इफ यू आर सेइंग दिस यू आर वेरी सीनियर फॉर मी, योर ब्लेसिंग्स। और राजन भाई के साथ तो शायद मुझे पता नहीं, राजन भाई 15 साल हो गए या 16 साल हो गए काम करते हुए, बहुत
आपका
जगह
शुभ
ट्रैवल
नाम,
किया।
आपका शुभ नाम क्या है?
मेरा शुभ नाम तो सर मेरा शुभ नाम राजन भाई रूपल वैन सब के पास है।
आई होप हम भी साथ काम करेंगे।
श्योर
राजन
मैम,
भाई के साथ कर चुके हैं। राजन भाई
श्योर
के
मैम,
साथ बहुत इन्वॉल्व हुए हैं कहीं ना कहीं।
श्योर मैम, श्योर। सर अब अगला ट्रैवल कहाँ का बन रहा है आपका?
किस
मैंने कहा राजन भाई आपका नेक्स्ट ट्रैवल अब कहाँ का है?
अब देखिए, ये कोविड ने तो सब चीज पे ब्रेक लगा दी है। सोच भी
वेरी राइट,
थोड़े और 3-4 महीनों का इंतजार करते हैं। पिछले साल तो नेपाल की बहुत मुलाकात हुई।
हाँ,
इन दैट रिकंस्ट्रक्शन प्रोग्राम वी हैड वंडरफुल ट्रिप्स। एंड अभी तो प्रोजेक्ट खत्म नहीं हुआ, मगर फरवरी से सब बंद हो गया। तो प्रोजेक्ट चल रहा है स्काइप के जरिए, व्हाट्सएप के जरिए, मगर जो मुलाकातें होती थी विच वंडरफुल टाइम। रियली मिसिंग आउट ऑन दैट।
कोविड ने काफी टाई अप कर दिया सर, सबको बांधा है सबको।
कोविड है, नहीं कहीं जाना भी नहीं है अभी। आई मीन यू वांट टू बी सेफ, राइट? हाँ, yeah, very good formal.
Sir, ma'am, actually, our other coordinators are facing some issues, technical issues. So we will wait for a few more minutes till they get connected with us, sir.
प्रोजेक्ट पे
Ma'am, you were muted. Please speak again, ma'am, please.
हाँ नितिन, आप किस प्रोजेक्ट पे काम कर रहे हैं आजकल?
Can you hear me now?
Now I can hear you.
Yes, ma'am. We sort of take up small projects with. I mean, our project profile is not what the extent you people at DDF kind of take up. But we are now engaged with the World Bank for the repairs on the seismic retrofitting of the World Bank itself. Then with the corporate clients we have like Novotel Hotel chain and Airtel Teams. So
Okay, sir, let me check once. मैं आपको
Airtel for us is a long client. I mean, we are doing their 8th or 9th building nowadays.
Okay.
And then there are people like L&Ts and things like those. Unka bhi hai. So L&T calls up for all the retrofitting jobs. We are, I mean, the last feather in our cap was Delhi Metro. Last year you would remember there was a fire in the Delhi Metro line 8.
Yes.
Line 8 at Kalandi Kunj.
Mm-hmm.
So we have designed and we have retrofitted that line and
Okay.
handed over back to DMRC.
So basically, are you doing only retrofitting project or you are doing otherwise architecture project also?
No, ma'am. Only and only repair and retrofits. That's all. That's a very small niche market. Small niche market. Matlab, I mean, either you can go mile wide and inch deep. I mean, we chose to go only inch wide and mile.
Fine. So you get connected with me. I will take your phone number.
Sure, ma'am.
And
Sure.
we will discuss the details of various projects.
Of course, ma'am. Of course.
So
I
we
will.
can work together.
Yes, ma'am. I have your mobile number now. I mean, I guess they have made a group.
WhatsApp group, yeah.
WhatsApp group. There, your number is there. I'll connect with you, ma'am. After this meeting, I'll connect with you. I'll do that.
Okay.
It's, yeah. We should meet as well sometime.
Definitely.
Mr. Amit Bose as well. I mean, we keep meeting passively here and there, sort of arrangements, but we haven't met directly.
Actually, we are not going out of the house at present. We are doing only the web meetings.
No, I understand that, obviously.
Both of us are senior citizens, so we are not going to. Our office is open, but we are
Operational,
not
yes.
going to the
Okay.
office. Really.
Okay. Ma'am, for us, we have to work from office. So for us, there is
Our office is also open.
so वो है थोड़ा सा.
वो तो जाना ही पड़ेगा बिना office.
You are right.
हमारी तो टीम है तो वो देख लेती है ऑफिस पूरी.
Ma'am, you have risen to that level ना. हमारे को तो we are still at that level where we have to push everything.
नहीं, आपके बारे में तो सभी जानते हैं, सब आपको पहचानते हैं बहुत.
नहीं, ma'am, that's your blessings. Blessings, ma'am. I mean, I was working with UN and seeds and organizations till 2012. 2012 mein I started this company, Aadhaar Consultancy, for retrofitting purposes only, and that is what Aadhaar Consultancy.
Okay.
Mostly only that we take up. I'll share things with you, ma'am. After this meeting, we will connect certainly.
We will talk in the evening or after the meeting. Fine.
After the meeting, yes, ma'am. Sure.
Fine. So who else is joining, Amir? Nobody else has joined. And I think Mr. Desai is also got disconnected. Let's see him.
Ma'am, Avdesh has recently joined. He is our collaborating partners. We are waiting for the Vice Chancellor and Dean to join as well, ma'am, from Invertis University.
So you are in civil engineering department there?
No, ma'am. My background is from geology, actually. But I'm learning with each step.
Okay. But you are in civil engineering or sciences department there?
Sciences department, ma'am.
Fine.
इनको बना देना है पूरा इंजीनियर with geology background.
Sure, sir. Why not, sir?
और मैम थोड़ा सा वेट करना पड़ेगा क्योंकि जो कोलैबोरेटिंग पार्टनर हैं इन्वर्टिस यूनिवर्सिटी वाले, दे आर स्ट्रगलिंग विद सम टेक्निकल इश्यूज, सो वी हैव टू बियर इट आउट.
अब वैसे तो
अच्छा, अवधेश हैज ऑलरेडी जॉइंड. अवधेश जी, यू आर वेलकम टू द ग्रुप.
अब अगर तुम्हारे ऑफिस में होते तो कॉफी पीते, अब तो ऐसे इंतजार करना पड़ेगा.
मैं कॉफी का कप दिखा सकता हूँ, मैंने पानी गर्म किया था बट अभी पोर नहीं किया है.
ठीक है, पियो.
Hello. Hello.
Yes, sir. Yes, Abhi, sir. Good afternoon, sir.
ma'am. Now I'm connected, and VC sir and Dean sir is going to join shortly. So I think you have mailed the new link to all.
Yes, sir. I've just mailed them. Yes, sir.
Okay. Now I'm coordinating with them.
अवधेश साहब गुड आफ्टरनून, कैसे हैं आप?
Sir, namaskar. Good afternoon, sir.
ये वर्चुअल में और टेक्निकल के साथ यही रहता है, कभी भी आप फंस जाते हैं.
हाँ सर, मैं बस कोऑर्डिनेट करके सर से अभी ज्वाइन.
हाँ, प्लीज टेक योर टाइम.
ओके सर.
And for the participants, you have to bear with us that we are just waiting for more panelists to join, especially the dignitaries from the Invertis University, the collaborating partner. So we have to wait for another few minutes till the time we have all these entire panel on the board. So sorry for this delay. We are just waiting for the entire panel to join, especially Vice Chancellor and Dean Research from Invertis University.
Amir sir, what
Yes,
is the profile of the people who are, the attendees?
Majority of them are engineering background. Civil engineering background.
From the university.
Yes, Invertis University and others as well. So हमारा focus जो हमने publicity किया है वो engineering fraternity में किया है.
Okay.
But it's open to everyone. But majority of them are engineering background.
Okay.
Students, teachers.
Okay.
And all of them.
Okay.
Adesh sir, are you listening? Dr. Adesh Kumar, are you listening?
Sir, actually, I've just talked to Avdesh sir. He is going towards VC sir. So probably he is assisting in that. So he said he will, in 5 minutes, he will join. So we will start in anyhow.
I think we shall start, and as soon as Vice Chancellor is available, we can
Yes, sir. Yes,
involve, ask him to read out his message.
Okay, sir.
है ना?
Okay, sir.
So let me talk to him. Okay, just one. Arya Sahab, good afternoon. This is Dr. Amir from NIDM. Can you Avdeshji, can you hear me? Yogita, can you hear me? Arya Sahab is already there.
Hello.
Avdesh Sahab,
Hello, Dr. Amir, can you hear me?
I can hear you.
Okay, okay. VC sir is connected. Now I'm going in my cabin. Sir,
Okay.
Start my video.
Stop.
हाँ हो गया ठीक
Yogita, can you unmute me?
Sir, it's already unmuted, sir. We can hear you, sir.
Mute करिए. हो रहा है.
Sir, I can do it on your behalf, sir.
ये तो आ रहा है ना दोनों साइट जब तक वो करो तब तक अब इससे तो कुकी नहीं क्रिएट अभी तो क्रिएट नहीं है ये तो क्रिएट नहीं कर देगा अभी जो हमने किया है वो कैसे क्रिएट होती है
वीडियो
साइट ही बेकार चलो मैं तुमसे बात करूंगा चल जाना चाहिए
Hello, Amir sir?
I can hear, but I think my system is not. I am having some technical issues now.
Sir, I can mute unmute from your side. That is not an issue.
It's okay. So, Avdesh, can we start? I can be. Let me try to join through this. Avdesh, can we start now?
Hello, Avdesh sir, can you hear us?
Avdeshi, can you hear me?
हाँ आ गया सर. Hello.
Avdeshi.
Okay, sir. I think all the dignitaries, respected dignitaries, and all the respected speakers are connected now.
योगिता मुझे शिफ्ट करिए.
Okay, sir.
Hello. Sir. Dr. Amir, sir.
Please go ahead.
Okay, sir. So let's start the program. Very good afternoon, present here. The Indian subcontinent has a history of devastating earthquakes. Geographical statistics of India show that almost 57% of land is vulnerable to earthquakes. Of these, about 12% is vulnerable to severe earthquakes. The earthquake in Bhuj, Gujarat 2001, there has been observed a need of concerted effort to address the seismic vulnerability of buildings in India. Huge devastation during various earthquakes established the fact that the active don't kill the people, but a poorly designed building do. After accepting the aftermath of earthquakes over the world, a great number of people lost their life due to poorly constructed buildings. It is a widely known that the fatalities from the earthquake are a man-made problem, so there has to be a man-made solution. Retrofitting, on which today's webinar is focused, is the modification of existing structures to make them more resistant to seismic activity, ground motion, or soil failure due to the earthquakes. With a better understanding of seismic demand on structures and with our recent experiences with large earthquakes near urban centers, the need of seismic retrofitting is well acknowledged. So holding this webinar is to disseminate the information about earthquake retrofitting for disaster mitigation and resilient development among the participants and delegates. So to disseminate the information about the structural retrofitting for earthquake risk mitigation among the participants and also to create a vast multidisciplinary understanding of issues pertaining to the safer buildings, resilient infrastructure, and best practices among the society, NIDM and the Invertis University Bareilly have jointly organized the webinar on structural retrofitting for earthquake risk mitigation. I formally welcome the Honorable Chancellor, Dr. Umesh Gautam sir, in his absentia, Vice Chancellor Dr. Y. and Executive Director NIDM, Major General Manoj Kumar Bindal sir, to this webinar as our patrons, and our Dean Engineering and Technology, Dr. R.K. Shukla sir, and Dr. Amir Ali Khan sir of NIDM as esteemed program chair. I also welcome all the respected speakers and participating dignitaries and delegates who have joined us today. Now, with the kind permission of our patrons and program chair, we begin the inaugural session of the program. Sir, can we begin? Hello.
We
VC,
shall
sir?
go ahead. Right?
Yes, sir.
Okay.
Sure.
Thank you, sir. So first, in the inauguration session, I would like to invite Vice Chancellor, sir, Dr. Vaidya sir, for his keynote address. And before that, I would like to give a brief introduction of our Vice Chancellor, sir. Dr. Arya is the Vice Chancellor in Invertis University, is an alumnus of IIT Kanpur, having worked with Sun Microsystem USA and Fujitsu Japan. VC sir joined Invertis University as Director Engineering, and today he's joining the coveted post of Vice Chancellor in Invertis University. Sir is also in the also is a eminent computer science expert panel and of various university, and he is also a National Board of Accreditation expert of AICTE. We are honored with his presence here today. I would request Honorable Vice Chancellor, sir, Invertis University, to kindly deliver his keynote address, please. Over to you, sir.
Thank you, Avdesh. Well, I welcome all the NIDM participants, organizers, and Invertis faculty, also my colleagues, Mr. Avdesh and others. It is a matter of pleasure to really take part in the events organized by NIDM. This is somehow the new section of NIDM, but otherwise we are regular, members or collaborators with NIDM, with Dr. Gupta and Dr. Panda in their department. I don't know the details, but anyway, this is also a very interesting, very rather core subject of structural retrofitting. As I understand, it is that how do you build buildings which taking care of earthquake resistance. Actually, once I visited IIT Kanpur after I joined here, then there is a complete department there, and they were actually trying to vibrate a complete wall, and they were trying to find out how much damage it will be there. So there is an earthquake department lab itself. So, and nowadays it has become more important because nowadays buildings are not only 1 or 2 stories; they are huge structures, and structures with lot of lot of money involvement. They are huge and big and massive structures. So you can't take chances that tomorrow something happens and you lost. So a loss will not be a minor; it will be a very, very huge loss. And not only property, it may be loss of lives also. So it is really, really very important that the building you make should at least be resistant to the known kind of threats. Unknown, you never know. As you know, it happened with the twin towers. You might also be knowing, or the comments afterwards we got, that this building was not supposed to burn, but they could not estimate that this much heat will be generated. So there are always new factors which come only after the event happens. So leaving apart those kind of things, what we know, we should be sure that it will not damage, or damage will be very minimum, which can be handled. But anyway, this is a very important factor for engineers, especially civil engineers, structural engineers, that they should make buildings which are really resistant to the known threats. Unknown threats one never knows. But anyway, unknown threats are less than known threats. So this will be very good deliberation, and it will be a lifelong learning for my students and other participants whosoever are joining it. So it is a very core subject, and students should find it interesting, and not only they should be very serious and put questions. I'll request the speakers to kindly give time for questions, because if you will answer questions, then things will become more interesting. It will not be in middle, but after your lecture is over, so please answer their queries. And I wish that out of 10 students, at least one ask questions, because the literature is available anywhere nowadays. You can study any book by any famous writer or very competent writer, but that does not give the feeling of interaction. What is your question? What is my teacher's answer? So these kind of things only make these kind of sessions important or interesting. So I wish that speakers keep this with their mind that they have to answer the queries, and they should make it lively, and maybe if you can ask feedback in between also, it will be more fruitful. So with these words, I once again thank Invertis University and NIDM, this section, to organize such good events for the benefit of the learners. Thank you very much.
Thank you, VC sir, for
For
your.
those who are not aware, this is Resilient Infrastructure Division of NIDM, through which we are organizing this program.
Okay, sir. Okay, sir.
Okay. Resilient Infrastructure Division is here.
Yes.
And very good, very great inaugural session, lecture was given by our Vice Chancellor, sir. Now, in the line, I would like to invite Dr. Amir Ali, sir. And Dr. Amir Ali Khan, sir, is a trained civil engineer and urban planner with a PhD on urban earthquake risk mitigation. He has a postgraduate diploma in studies of geological risk from University of Geneva. In addition, he has been trained by several international organizations on the subject related to disaster risk management and mitigation in Asia and Europe. Dr. Khan has served UNDP for about 2 years as National Disaster Reduction Advisor in Uzbekistan. During his stay with UNDP, Dr. Khan served as chairperson of the UN Uzbekistan's Disaster Preparedness and Response Group. He was also the UN focal point on humanitarian assistance. He was varied experience in area of disaster risk mitigation and management at national and international level for program development and management, knowledge management and communication, capacity enhancement, partnership building and networking, etc. His currently areas of interest include capacity building for earthquake risk mitigation, especially in urban areas, post-disaster reconstruction and rehabilitation, mainstreaming disaster risk reduction into development and formulation of disaster management plans. Over to you, sir. Dr. Amir, sir.
So it's thank you so much, Vice Chancellor Saab, Arya Saab, for allowing us to organize this wonderful initiative in collaboration with Invertis University. Definitely, it's a pleasure to be here, and sorry to all the participants and all the dignitaries for this slight delay. So, as you know, that the Resilient Infrastructure Division of NIDM is involved in various activities related to disaster risk mitigation, particularly earthquake-related activities. And in this series, we are organizing this program of retrofitting of structures for earthquake risk mitigation. And as you know that Arya Saab mentioned about twin towers and all those things. So retrofitting plays a very important role. What is retrofitting? Just for those who are not familiar, is that providing additional strength to existing structures to face future earthquakes. So that is seismic retrofitting. So we have to work with old structures and how to arrive on retrofitting and criteria for retrofitting. We have to evaluate those buildings. There are set procedures, and after certain time, all buildings require that strength. So we are escaping first 2-3 steps, and then we are directly dealing with the retrofitting techniques. And for dealing with these different aspects of retrofitting, we have eminent panel of speakers. And as you know that this panel includes Madam Bose, Pratima Rani Bose, Dr. Rajendra Desai, and Dr. Nitin Verma, who are dealing at national level in a big way. And those are the core professionals working in retrofitting area. And why we go for retrofitting is because as I told, my division is having that resilient infrastructure type words in the title of my division. So resilient infrastructure plays a critical role at the time of disasters, and we have to sustain those structures at the time of disaster or post-disaster scenario. To take a name like hospitals. So hospitals are immediate requirement after a big disaster. Whatever type of disaster you are dealing, forget about earthquake, you go to cyclone, you go to floods, you go to fires. So we have to make structures safe against all those hazards which are prevailing. But today we are focusing on earthquakes. So earthquakes not only killing people, they are destroying the infrastructure as well. So there are instances at national level when buildings have collapsed, hospitals have collapsed, schools have collapsed. all those infrastructure facilities from transmission towers to communication towers to roads and bridges to everything has collapsed. So through this effort of today, we are just trying to focus on providing additional strength to existing structures. And this is, I think, a humble beginning to sensitize the participants on different facets of retrofitting. And today we are just covering two aspects of masonry retrofitting as well as that framed structures or RCC retrofitting. So, and as we are going to have planned some more activities, and there are more techniques available for retrofitting of structures as well, critical infrastructure as well. So these two eminent speakers are sharing their experiences of providing additional strength to existing structures in those two environments, art masonry as well as framed structure or RCC environment. So with this, I just conclude here. I want to listen to more on these experts, and Mrs. Professor P.R. Bose is going to set the tone for today's thing by posing some challenges and need for retrofitting programs at national level. So with this, I just conclude and hand over to Avdeshti, so you can formally introduce the speakers.
And its concept, and especially its effect on the critical infrastructure damage like hospital and other necessity infrastructure. Now, I would like to invite Dean Engineering Dr. Ankit Shukla sir, and he himself has a very keen interest in civil engineering and very good knowledge of retrofitting too, and he's always a very show very keen interest in civil engineering department's activities and the new discoveries. So before that, I would like to tell the participant about Dean sir and Dr. Ankit Shukla sir, Dean Engineering and Technology. He's Dean in Engineering Technology, Pharmacy and Agriculture here, and has a 21 years wide teaching and administrative experience. And he authored many books in mathematics and contributed significantly at national and international research. He is a dynamic visionary, and under his able leadership, engineering and civil engineering department of the Invertis University has consistently grown to new heights and has set high standards of achievements. Over to you, Dr. Shukla sir.
Thank you, Udesh. Thank you for giving me opportunity to address the audience. Honorable Chancellor and Mayor Bareilly, Dr. Umesh Gautam in absentia. Executive Director in NIDM is General Manoj Kumar Bindal ji, awarded Basis Seva Medal in absentia. Dr. YDS Arya, Vice Chancellor, Invertis University, Bareilly. And the speaker who has spoken, Dr. Amir Ali Khan, NIDM. Today's eminent speakers, Dr. Pratima Rani Bose, former Principal Government of Engineering College, Jafarpur, Delhi. Architect Nitin Verma ji, DGM Technical ASE Noida. Dr. Rajendra Desai, Joint Director and Managing Trustee, NCP ADP Ahmedabad. Program Convener, none other than young and smart boy, Engineer Avdesh Kumar, Assistant Professor, Invertis University, Bareilly. And Program Moderator, Ms. Yogita Garwal, Young Professional, NIDM. Mr. Sarvan Gupta, Head of Department, Civil Engineering, Invertis University. Mr. Arvind Kumar and all faculty members of Civil Engineering, Invertis University, Bareilly, and all the participants of the webinar. I welcome you all on behalf of Invertis University, Bareilly. Today we are organizing the 6th webinar in association with National Institute of Disaster Management, Delhi. It is a matter of great privilege for both of us, and I appreciate the efforts put on by Mr. Avdesh Kumar organizing the series of webinars, which are really knowledgeable and useful for the society. After all, we are working for the society. Earthquake is very uncertain and its effects are devastating. Huge structures get collapsed, which resulted life and economic losses. Many of such incidents has been witnessed in our country as well outside country. which highlighted the need of the strengthen the buildings and structures of the country or entire world. Retrofitting reduces the vulnerability of damage of an existing structure during a near future seismic activity. It helps in increasing the strength and resistivity of the structures, which gradually increase the lifespan of the buildings and structures. Today's webinar on structural retrofitting for earthquake risk mitigation will be resourceful and conversant for all of us and will lead us toward the solution. I will not take much time, and it is time for the expert to speak about this webinar. Thank you very much, Avdesh, for giving me opportunity to speak about this. Thank you so much.
Thank you, sir, for your kind words and insightful remarks. And definitely, it's going to the sixth webinar is going to prove very beneficial for the young professionals that are attending today from Invertis University and all other participants who are attending from different corners of the country. So, with this inauguration, now I would like to again invite our program chair, Dr. Amir Ali sir, and for complexity for beginning of the technical session of today's program. Sir, over to you.
Avdeshji,
Sir, please.
Can you directly go to invite and Mrs. Professor Bose?
Okay.
We are already late.
Okay, sir. Okay. So now we are going to get the opportunity to hear Pratima Rani Bose ma'am directly. So she's going to deliver his context setting remarks on need for on retrofitting of structures for earthquake safety. And before that, I would like to let the participants know about ma'am's work and his profile. So Dr. Mrs. Pratima Rani Bose is the founder, principal of Government Engineering College, Jafarpur, New Delhi. She's currently heading the Structural Engineering and Disaster Management Division of DDF Consultant Private Limited, Delhi. Presently, she is involved and helping in several consultancy projects related to disaster management, earthquake, and cyclone-resistant design of structures and disaster risk reduction planning. She is former principal, CBP, Government Engineering College, Delhi, and former professor and head Department of Civil Engineering, Delhi Technological University. Before this, she also worked with the Department of Earthquake Engineering, University of Roorkee, and now it's IIT Roorkee. How for 20 years she did her for 20 years she did her BE Civil and ME in Structures and degrees from the University of Roorkee and PhD from IIT Delhi. Ma'am Bose is a life fellow of Indian Society of Earthquake Technology (ISET) and life member of many other professional boards. She has served as the chairperson of the Delhi chapter of ISET. She served as a member of various committees contributing in the development of Indian nodal provisions related to the earthquake engineering. She has published more than 90 technical papers and has guided more than 50 ME dissertation and 4 PhD theses. She is an expert speaker to a number of organizations in India for short-term, national, and international continuing education program. Ma'am, kindly enlighten the participants with your voice of wisdom. Please, ma'am. Over to you.
Kindly give me the right to share the screen.
Ma'am, Yogita ma'am, please.
Yes, ma'am. I'm just giving you. You have the rights, ma'am. Please continue.
So how I will connect?
Ma'am, just go to the share option and you can share your screen or your file, whatever is there.
Fine.
Yes, ma'am. It is coming.
It is coming?
Yes, ma'am. You just maximize your presentation and it will come, sir.
Okay. I think you can see it.
Yes, ma'am.
Okay, thank you. Thank you, NIDM. And thank you, Invertis University, all the dignitaries sitting here. A very humble good afternoon to all of you. It is a pleasure to speak in front of the young. Our students may be attending it. So it will be a pleasure to answer their question. Any question they feel like they can put it to me. And the other speakers, they all will like to answer the young questions raised by the younger ones. First of all, let me ask how much time you will give me, because we are already short of time, so I can finish within the time.
So how much time do you need, ma'am?
Huh?
How much time do you need?
I can speak for hours.
No, but minimum as minimum of the limit. Because you are setting the tone of the program, so we need to listen to you as well.
Okay. So I will try to finish as early as possible, because
please, with we are already late, so you understand all these things. Yeah.
Yeah, definitely. So I will try to skip many things and come to the point. Okay.
Okay. Thank you, ma'am.
So definitely, first is why retrofitting? Why retrofitting is required for earthquake risk reduction or for earthquake safety? Because a large number of existing buildings are there which are not non-compliance to the earthquake code. When they were built, nobody bothered about the earthquake codes and built those buildings. Then revision of the code, continuous revision of the code is going on. So that is one of the reason. Sometimes we have to retrofit the building when earthquake comes and the buildings are damaged. At that time also we retrofit the building. Then sometimes we use the change of use is there in the building. Some residential building is used for the hospital, or you can say nursing home. Then we have to retrofit it from the seismic point of view. And definitely, if the deteriorated condition is there, we have to go with this. We have to go for retrofitting. So when we have to go for retrofitting, we must understand what is vulnerability, because your damage will depend upon the vulnerability. Earthquake is there. If you are in zone 5, you will remain in zone 5. If you are in zone 4, you will remain in zone 4. Only thing you can handle is the vulnerability of your building, existing building. So vulnerability depends upon many parameters. The main point is the structural design, and another is the architectural shape. These are the two important points which will affect the damage. Another thing is site and location of the building. Then definitely the construction defects if are there. Then the poor maintenance and material used. Masonry building or concrete building or timber building, or it's a random rubble stone masonry, it's a brick masonry. All this, every building will behave in a different manner and it will be having different vulnerability. So that means when we have to go for retrofitting, first of all, we have to assess the vulnerability of the seismic vulnerability of the existing building. There are various, you can say, vulnerability methods, assessment methods. One is the RVS, which is called Rapid Visual Screening Method. This is generally applied on a large population of the building. That means we may go for thousands and thousands of the building, and it may take only 1 hour or maybe sometimes half an hour to quickly judge whether this building requires retrofitting or not. So we identify the building and then we prioritize them, that these buildings, critical facilities are to be retrofitted first. This may be hospitals or these may be the schools at present. Now, after that, we have to carry out the detailed survey. Generally, the drawings, etc., are not available. So we have to go to the site, take measurement, prepare drawings. Then we have to assess the present condition, whether the building is cracked, is already damaged, or what is the situation there. Then we go for a simplified vulnerability assessment, which is based on some little calculations, but not on the detailed analysis. And at that time, we can screen some buildings, that these buildings may be demolished, and other buildings we may go for retrofitting, or these buildings do not require retrofitting. Then finally we go for detailed vulnerability assessment, and for that we have to use some codes, guidelines. At present, in India, we do not have a code which guides you for the detailed vulnerability assessment. The code is there for masonry as well as for the, you can say RCC also, but for using that, you can do the simplified vulnerability assessment only. But definitely the guidance is there about the retrofitting of the buildings. But still we have to go for a code. We must publish a code in which the detailed guidance is given about the retrofitting. And finally, when you design your building and you check this building and you retrofit it, you design a scheme, and with that scheme, you retrofit the building. After that, you have to apply a check and you have to see whether your building will perform up to that level or it will not perform up to that level. And all these aspects will be covered by Mr. Nitin as well as Dr. Rajan, because they will be speaking about the masonry building separately and RCC building separately. So I am not going into the details of it. What are the challenges you will face when you will go for retrofitting? First is there will be no drawing. You have to prepare it. No structural drawings, no architectural drawings. Easy to prepare the architectural drawings, but very difficult to prepare the structural drawings. Now, when NDT test, for that we have to conduct the NDT test because we don't know whether it is M20 concrete or M25 or M15 or even less than that. So we have to conduct the NDT test. We have to check whether the earthquake resistant measures are there or not. And we cannot do this test on 100%. We have, it is not possible at all. So we have to select some samples and on that we conduct various tests and we come out that this is the present, you can say permissible stresses. These are the permissible stresses for which we have to check the building. Then we have to go for, because soil reports are also not available. So we have to go for soil investigation also. And soil investigation is also not possible as it would have been done at the construction, at the time of construction. So we do in nearby area maybe 1 or 2 tests and we go for it. Non-structure I am not covering. Now that means we have to train a lot of people. This is the program you are doing for capacity building, for mostly for the engineers, but you have to train like this, architects, structure engineers, geotechnical engineers, and it is not the work of only civil engineers, it is the work of the electrical, mechanical engineers also, because your non-structural elements will get damaged, and until unless they are aware about the retrofitting, they will not be able to carry out the retrofitting of the non-structural elements. So you have to train all the key players. Then comes the cost of retrofitting. Now, after analysis and after doing the retrofitting, you estimate the cost. Now, that means the cost which you are working out, if it is equal to the cost of a new building, nobody will go for retrofitting. So it has to be less. But there has to be a limit. In earthquake guidelines, some limits are given by the NDMA, that it may go up to the 50%, or in some unusual cases, it may go to the 70%. So after doing all of the work, you will come to know what is the cost of retrofitting, and then the decision from the authorities will come whether they would like to go for retrofitting or not. This is a, you can say, very, very constraint to the retrofitting. Another thing, people think that retrofitting is just a repair and it will hardly take any time and hardly, the consultant will hardly devote any time. But it is not true, because retrofitting building has to be analyzed several times, because we have to try different options. And the cost of audit or cost of, you can say, the retrofitting design becomes very high. And that is not accepted by the people or by the owner of the building. Now, just to give you an idea about the picture, clear picture, how many buildings are to be retrofitted, I have just worked out very rough, very, very rough estimate from 2011 census of the houses, and it says that the total about 36 crores, 30 crores are there. So out of that, I say that masonry buildings are 80%, and which comes out to 24 crore, and 70% you can, sorry, 1.3% are RCC. So if 80% of that are earthquake, not earthquake resistant, then 24 crore. If 70% are not there, say, rather I will say 80% are there in zone 4 and 5, and 70% are there in zone 3, 4, 5. So this comes the number. And out of that, if only 50% needs the retrofitting, then you can imagine 12 crore masonry building needs retrofitting, and 50 lakh concrete building retrofitting. So that is the real picture, and that is the, you can say, size of the problem we are facing, and we have to go for retrofitting. So what we have to do now, capacity building, which you people are doing, Invertis University and NIDM. Then we have to go for modifying the code and guidelines, prepare new codes and guidelines for different typology of the building. We have to in that we have to give the approach methodology and for various type of buildings. Then comes the earthquake data. When you go for the non-linear buildings, you require a large amount of earthquake data which is not easily available, and that sometimes gives hindrance to the designing the building to a particular performance level. And finally, the techno-legal aspect is very important, because when you go for retrofitting for a multi-story building, there may be 100 flats, and 100 owners will not like to go for the retrofitting. So how to handle such a situation? So techno-legal problems are also there which are to be resolved. So still we are struggling, we are doing the retrofitting, but much more is required and much more is to be done. Thank you very much.
Thank you, ma'am, for setting the tone of this webinar. And definitely it has to go a long way. And thank you so much for accepting the invitation and showing us the path for retrofitting of these structures for earthquake safety. Avdesh, you can go ahead.
Okay, thank you, ma'am, for your greater context setting, and you tell us about the various vulnerability assessment techniques like RBS, STA, DBA, and also you tell us about the various challenges like creating a structural drawings, that is the architectural one, Ndt conclusion drawing, and you also throw light on the cost of audit and retrofitting. A number of vulnerable building. It was a really shocking data, but it was expected that building codes negligence is a reality in India. So road, and also show us the road ahead. And thank you so much. Now I would like welcome our next speaker with his presentation on retrofitting of masonry structure for earthquake safety. He's an expert, Dr. Rajan Desai ji. And now Dr. Rajan Desai ji is currently serving as the Joint Director and Managing Trustee of the National Center for People's Action in Disaster Preparedness. He obtained his MS Structures Civil Engineering in 1972 from Rutgers University, New Jersey, USA, and after that, he has gained 20 years of diversified experience in technology development and transfer, structural design, disaster mitigation, rehabilitation, repair, seismic retrofitting of masonry structures, assessment and improvement of vernacular building systems, and site improvement of and site development in India, and 13 years of diversified civil engineering experience in USA. Desai sir worked as an associate member of Earthquake Engineering Research Institute, California, USA, and is a life member of Indian Society of Earthquake Technology. Since 1997, Rajan Desai sir has been a consultant to the Government of India, UNDP, UNCRD, UNESCO, Gujarat State Disaster Management Authority, Asian Disaster Preparedness Center, Bangkok, and Oxfam India Trust, and has published a number of guidebooks for the common man. Dr. Rajan Desai sir, ongoing training programs for skilled upgradation of existing masons, focusing on earthquake-resistant construction, primarily in Gujarat and other parts of India. Dr. Desai sir has worked from 1985 to 1993 at Center of Science for Villages, Wardha, Maharashtra, and ASAG Ahmedabad, and has also worked in civil engineering disciplines of structures, soil and foundation, land development, and civil works with various consulting engineering companies. He has received several awards and has honored with Distinguished Alumni Award by IIT Bombay. His other awards include A.S. Arya University of Roorkee Award 2000 for Disaster Mitigation and HARA Hari Om Ashram Hutko Award for Dissemination of Earthquake-Resistant Housing Technology in Latur in 1996. Welcome, sir. Over to you, sir, for your session.
Okay. Thank you very much. Let me start sharing the screen here, and okay. Real pleasure to be here on this platform and talking on our favorite subject, retrofitting of masonry buildings. Which basically myself and my wife and our group has been working in mission mode for the last 26 years. So sharing a few things from our experience. Now, already, of course, Mrs. Bose has talked about what is retrofitting, but essentially it is, adding or substituting parts or components to a device or structure to make it fit for the given context. If the context changes, then you need to do something. And give an example, in petrochemical, when a pipe size or a vessel size is increased, it's supposed to trend. In none of these cases, the support structure is demolished and rebuilt if avoided. This is a very, very common situation. So in simple terms, this could be considered as strengthening to match the changing requirements. Now, same is true in performance requirements against disasters, especially earthquake, when the structures need greater resilience. Now, we look at, all these big numbers from past disasters of death and destruction and damage and the amount of money used, these numbers are staggering. And it's in your hand that you don't become a part of such statistics in future disaster. Because India has a number of potentially destructive hazards, seismic hazard, wind hazard, flood hazard. Of course, we are talking about seismic hazard today. And buildings which are vulnerable to hazard are likely to suffer damage. And that it poses danger to the occupants when that hazard strikes. Now, such vulnerabilities can be reduced, if not totally eliminated, by retrofitting. Why opt for retrofitting instead of rebuilding? Number one, when you rebuild, reconstruction essentially means first the demolition, then removal of debris, and then construction. Each step involves cost and time. So basically, retrofitting essentially means making small changes to only some of the components of this existing building. So logically, it has to be cheaper. And by thumb rule, one can say that, it's about 5 times cheaper than reconstruction. Now, also needless to say, it is much faster than reconstruction. I'll give an example. We were working in Kashmir in a hospital, and it was a very large hospital, and it took us 2 months to retrofit that hospital. But if that were to be reconstructed, it would have easily taken 2 years or more. So also retrofitting, it means that the conveniences which were created in the you make it home by adding a lot of things. So most of these things are not lost. Reconstruction essentially means that you have to redo everything. Some more things. Retrofitting has a major advantage that it can be done in phases. So, it can be done on parts of the building, and it can be done at different times. So essentially, the use of the building also can be continued while retrofitting is going on. That particular hospital we retrofitted, we were given part of a wing of the building at a time, part of the floor. And then, slowly, as we finished each part, we moved on to the next part, and we could do the whole building while the hospital was functioning full blast. One more thing, because it can be done in phases, economically also easier to manage. If you don't have all the money you need right now, you do part of it as the funds allow you to do, and later on when the funds are available, you go further. Obviously, this results in huge savings of national and global resources. It has a very, very small carbon footprint when compared to rebuilding. So, especially in today's time of climate change and global warming, this is the green option, for reducing the vulnerability. So, in can ensure long-term safety against future earthquakes for most number of people with least amount of money. And so the money will go a long, long ways. Now, to reduce the vulnerability and to ensure safety, the most common approach in our country has been to demolish and rebuild, as it's easier to work clean slate. Nobody wants to work on something that's already there. So, but the question is, will there ever be enough resources to demolish and rebuild all these buildings? Mrs. Bose said about this huge number of buildings, 12 crore masonry buildings. Would there ever be enough money and time to rebuild all that? All right. So would it not be better to restore, the damaged buildings? If they're not damaged, don't have to worry about restoring. To retrofit these buildings so that, they become safer and the money would go longer. So essentially, we should be saying no to reconstruction. And quickly, we, like I mentioned, we have been working for the last 26 years in the Sweden mission mode, and all started in the immediate aftermath of Latour earthquake. So it was basically Latour where we did a lot of work. We retrofitted 150 houses. Then we had a small earthquake in Saurashtra region in 2000. Then came the famous Kutch earthquake. So we worked for about 3-4 years there. Of course, then the Chamoli earthquake at the same time, and then Kashmir earthquake. A lot of this was post-disaster. And back in Delhi in 2006-07, it was also like a pre-disaster mitigation work we did, for the government of India. And in last 3 years in Nepal, we've been working on rent-vulnerable houses in the mountains. So all different seismic zones we have worked in India. Now, very quickly, how to retrofit the building. You have to document the structure. If you have the as-built plans, great. But in India, typically, that's difficult to find. So you have to document the structure, architecture, structural, understand what exactly has been done. We need to remove the plaster to understand if what has been done under the plaster. Based on that, identify the weaknesses. Next, to identify the remedies of how you will tackle those weaknesses. If there's any damage, you repair that so that you restore the structure to the state before the disaster struck. And then you decide the sequence of operation. How are you going to go about doing it? What kind of phasing you will do? And based on that, you procure the materials and you go on with the retrofitting. And what you may want to hide completely all has been done, so you do it so that you match the finish with the adjacent surfaces. Or as we have been doing, we highlight the retrofitting measures. We want them to be conversation pieces. People should come and ask, what is this? Because you want to create interest. And of course, there are non-structural damages, which some of that may have to be done before you retrofit. Some of it is done after after you do retrofitting. Damage to parapet and chimneys are the classic non-structural damages that you would do before you would retrofit. So, all right, very simple building here, a square building. How do you document? Sure. You you draw plans, you draw elevations, you draw sections, but also if the building is damaged, for greater clarity, you prepare fold out, so you have this plan A, B, C, D, so all you do is you fold out like you would open up a cardboard box, and on that you mark out all the damage, you mark out the damage grade, you mark out the extent of damage, so ultimately that enables you to decide what is to be done and how much it's going to cost as far as the restoration of damage is concerned. All right. Now, what are the weaknesses? Now, typically, weaknesses are best manifested after the disasters, because when things break, things collapse, they tell you a lot of things. Now, something like this, a total collapse can, of course, say a lot of things, but it will at least say that it's poor quality masonry. And when a wall clearly separates from the other wall, it says that there was action to begin with between the two walls. I mean, this is a common thing you see. You see a masonry structure coming up, and you find out that one wall is built at a time with two things left out. So obviously that connection is useless. So all right, when you see something like this in the lower left picture, this that there was maybe there was absence of gable band and there was absence of connection between the roof and the gable. And something on the right side of the picture, it shows there is poor in-plane shear strength, which causes vacuum shear damage. So all similar things, they give you a fair idea of the prevailing practice. All right. So based on this, you can decide what the weaknesses are there in general, and based on that, you decide what features are required. Okay, some more examples of the weaknesses, especially in the stone areas, whether it is Latur, or it was Nepal, or Kashmir, or Uttarakhand, or Kutch. Delamination of the faces of random rubble walls is very common. And the prime reason is absence of through stones and also interlocking. So while the thing is built, it is weak. All right. Something very common, you find crack at the base of the gable walls. And what does it say? It also says there is absence of roof. Diagonal crack in this wall, it tells you that there is absence of bands. And something like this, a masonry column that is cracked, obviously it is without reinforcement inside. So, so the most common measures, retrofitting measures, is for random rubble masonry is cast in situ RC stitching element which stitches the wall faces together and prevent delamination. There is seismic belt if the bands are missing. There is gable belt if the gable bands are missing. Opening encasement. If the openings are not encased, then you have to provide encasing on the face of the wall. If there is vertical reinforcement missing within the masonry, you have to do vertical reinforcement on the wall. If the roof is not anchored, you have to anchor that. If the diaphragm is missing, especially the stile roof or slate roof, then you provide diagonal ties or braces. In case of timbered structure, timbered beams and column like what we had in Latur, or in Uttarakhand or Nepal, and you have timbered decks resting on timbered posts, you provide knee braces to stiffen the structure. And masonry columns without reinforcement, sure, you do jacketing. So let's very quickly look at some of these measures. Here is the RC element. Essentially, it requires making 2 holes in random rubble masonry. You do it very, very carefully. And what you do is what you see in that little detail, that you put concrete, you put a rod, and essentially you are stitching the the faces of the wall with a small element. All right. Next thing, if the band is missing, then you have the ferrocement belts on the faces of the wall made with weld wire mesh. And there could be some more wires. There could be some additional rods on it, depending on how much steel the mesh has, and it's anchored very securely. If the gable band are missing, you need gable band. It's very important that these features are anchored very, very strongly to the wall. Like I said, if the vertical wall is, the reinforcement is missing, then one can put the vertical splints of ferrocement and anchor it properly. All right. If the opening encasements are not there, once again, you provide the ferrocement elements on the faces of the wall so that the diagonal cracks from the openings would not occur. If the roofs are not anchored, which is very, very common, then you have to do anchoring. One of the most easy thing is to use galvanized iron wires. Very simple connection. One very common thing also is, today you find large number of openings in masonry walls. And as we all know, all these openings weaken the wall, especially against the in-plane shear. So one of the things you do is you can close these openings, right? Very simple measure. And if you have a slab, there's also need to anchor it, because typically slabs are built just simply placed on the wall with no connection at all, except maybe a bit of bonding and friction. So when you put the vertical reinforcement on the wall, you connect it securely with the RC slab. All right, some more measures, like I said, in case of timber, beam and frame, beam and post system, we provide knee braces to stiffen the structure. If there are masonry columns like these, very commonly you find in verandas and single-story structures and multi-story masonry structures, then you do jacketing using weld mesh, using reinforcing rods. In case of roofs, as I mentioned, you provide diagonal bracings. Now, diagonal bracings can be done both two ways. One is using, like say, 12 gauge GI wires. You can use multiple strands and make sure, you make sure that they are in X configuration, and they should be very tight. And you do the final tightening, by twisting these cable-like elements. Very, very easy to install. Your ends are very easily connected by simply tying them over the timber elements. The other option, which maybe engineers would like more, is providing the diagonal timber or steel elements, and of course these would require good end connection using gusset plates and bolts like that. This may be possible in some places. This may not be possible in a lot of the places, especially in remote rural areas. This would be difficult. All right. So, once you know what the weaknesses are, you go back to this fold out. And on the fold out, you show what kind of restoration you will do, as it's seen in this upper fold out, where you can see the cracks are to be grouted, and you see the splices across the crack. If there is what we call grade 4 damage, or part of the masonry has delaminated or has broken, or has collapsed, then you rebuild that. All right, so there's a bit of restoration there. And the bottom plan, you can see the belt shown and the to stitching elements and the corner splints. So this is very, very simple. Of course, this is a very kind of academic case I've shown, but on big buildings also you can use similar system to document and then to take up the work. Now, the things to remember, number one is that you assess, you have to meet the repair damage, and this is followed by reconstruction of the dilapidated or severely damaged elements. A lot of times you have situation, you may have RC elements, or you may have timber elements which are really bad shape, then you may have to remove them and replace them. All right. There may be, as I mentioned, certain portions of masonry which is in the state of impending collapse, as I say, grade 4 damage, a bit of shaking, and it's going to go down, or it is already collapsed. Then that you need to restore, you need to rebuild properly, and only after that you retrofit the structure. All right. Now, the next thing is that you understand the situation and use engineering common sense to evolve the solution. All right. The guidebooks and the codes tell you what, but how to do, you have to decide. All right. Also, you look at each building element and assess the vulnerability and strengthen it. And then also you look at the whole structure. All right. And as I mentioned, you be ready for the real life situation rather than simple textbook situations. There are always surprises awaiting. You remove the plaster and you find something that you never expected. All right. So also you demand adherence to right procedure, ensure the improvement in performance. We take so much of trouble to do retrofitting, and then you find that people are opting with shortcuts, job, then that is not going to bring any improvement in the mitigating the risk. All right. Finally, you need to exercise caution not to damage or weaken the structure. All right. And basically, as I say, you use the skill and trick rather than brute strength. Okay. I mean, when you are making hole in the wall, say for putting the stitching element, you can't be using a crowbar. A crowbar will easily create a crack in the wall. All right. The present scenario, what is the situation today? There has been very little retrofitting as a part of pre-disaster action. All right. Nobody thinks about it. Retrofitting is really like a vaccine. With so much of talk of vaccine today, right? But even this vaccine is right now, the disaster is already struck. I mean, that's the kind of situation happens in the disasters. You start thinking about retrofitting after the earthquake is struck. So what has really happened is that in the aftermath of disasters, we have been seeing this since Latur. We are witness to Latur, we are witness to Kutch, Uttarakhand, Kashmir, Nepal, you name it. And where largely, perfectly retrofittable structures have been abandoned or demolished, and they've been rebuilt. And why? Because few authorities promote retrofitting as the most viable for long-term security against future earthquakes. Secondly, people do not readily accept retrofitting as an option that can be adopted. They find it something very, very strange. We as human beings, we retrofit all kinds of things every day. A simple thing like a carton, old carton, we put tape around it, we put string around it, we do all those things. But we can't imagine strengthening our house. Why? Principal reasons. Number one, we engineers are the biggest culprits. We are the principal actors, and overwhelming majority is ignorant about this, or we find it economically unattractive. We think it's too much of a headache and we don't want to do it, and as a result, we don't recommend it. It's as simple as that. All right. So for building professionals, it's easier to start on a clean slate, which means you go for reconstruction. In rural areas, majority of existing buildings are of load-bearing masonry type. And once again, we engineers are ignorant about that. I mean, I came out of engineering college 50 years ago, and even then I wasn't taught masonry. So obviously when I go out, I said, hell, get rid of this and go for RCC. So this is what you see in disaster after disaster. All right. Just very briefly, urban areas, majority of existing structures are of RC frame type. And analyzing vulnerability of RCC building is a time-consuming and very expensive. That deters people. All right. In short, the delivery system for retrofitting does not exist today in India. You ask Ndt, he's one of the few who is doing retrofitting in India. All right. Now, okay, know-how about the masonry buildings, retrofitting. IS 13935 is the Bureau of Indian Standard Repair and Seismic Strengthening Guidelines. Very, very handy little book. And this is what we've been using for the last 26 years, all right, along with our own engineering common sense. And based on the work we have done, all right, we have made a number of publications. In Latur, we made in Marathi and English a manual for repair and retrofitting of traditional Latur houses. Okay. Later in Kashmir, after Kashmir earthquake for UNESCO, we made a manual. Later for BMPPC, we made a manual for retrofitting and repair for Himachal and Uttarakhand. And in the last 2 years in Nepal, for UNDP in Nepal, we have made retrofitting manual there. And in fact, in the last 1.5 years, we have evolved a new system of retrofitting using wires, what's called the containment reinforcement system, using wires and well meshes. So, but all these publications have been made based on the actual in field and coupled with hands-on training of the artisans as well as engineers. All right. And of course, they've been coupled with awareness campaigns, through meetings, posters, video shows. This is what is this is what is required to educate the government officials. All right. Confidence building. How do I know that Rajendra Desai, Rupal Desai coming and telling me that we need to retrofit and retrofitting will work? So we did shock table tests. This we learned from Professor Arya, a famous Professor Arya, was my guru unofficially. And in Latur, he did the shock test to show that retrofitting concept works when none of the government engineers were willing to buy it. And we adopted his design of the table. In Latur, we set up a table like this. Later on in Kutch, we did that. And then, we have been doing this in Ahmedabad. So it shows, you do the comparative test and you can see in very simple way that retrofitting does work. All right. Taking retrofitting forward. Today, as I say, retrofitting is in infancy in India. What the government really needs to do under managing disaster risk is to put top priority on the vulnerability reduction of the existing non-engineered buildings through retrofitting. All right, regional retrofitting guidelines for local construction systems are required because everywhere masonry buildings are also different. All right, so we need to do this. And there should be easy to understand information that local people, local artisans can understand, local engineers can understand. And we need to have vigorous training programs, awareness programs, so there is general awareness among everybody, and the public agencies owning buildings must be sensitized, assigned priority for retrofitting of this building. In Kashmir, we saw large number of buildings up to 2005, large number of school buildings which had gotten slightly damaged and they were demolished. All right. The materials required for retrofitting should be made available because without that, people can't move further. Standardization of retrofitting measures and SOR to be developed so that they can be inducted into the government system. SOR is the biggest stumbling block. In Uttarakhand, we experienced that again and again. All right, conduct on-site training of engineers, contractors, and building artisans so that building, retrofitting skills become easily available. All right. And in short, we create the retrofitting delivery system. So finally, number one, make saving of existing buildings a priority, not reconstructing. You have to be obsessed with saving the building. Then only you think of it. Number two, be happy with better if best is not a thing. Best is always the enemy of better. All right. Typically, engineers want, and I'm saying that in India, we don't have anything that's safe. We have things slightly safe, less safe, more safe, prepared for this because that is the reality. Every retrofitting measure will help reduce vulnerability. All right. So go for incremental approach. Funds on hand are not enough. Whether it is a school building or personal house. Okay. We can't wait for tomorrow. What funds you have, do it now. If you do it now, you will do it later. All right. And for given resources, retrofitting will go the farthest in bringing safety. So thank you very much. Thank you. Bye.
Thank you, sir. Thank you, Dr. Arvind, sir. Be happy with the better if best is not attainable. Sir, you beautifully explained why we ought for the retrofitting instead of rebuilding. And you nicely explained the concept of retrofitting is how it is cheaper because as when we discuss the retrofitting in classes also, and with the people when we have the conversation, then they say that it is too costly. So you rightly you very beautifully explained that retrofitting is 5 times cheaper and faster too in your session, and it is somehow an initial investment that will give a great result in the future in attaining the seismic resilience. And you tell us about the weakness in the machinery construction and documentation of damaged building. Various technologies are also discussed during your session, like retrofitting measure for weaknesses and retrofitting plants. And and the very beautiful thing that I personally like to, sir, that I would like to share that you discuss about the practical loopholes that exist in the society. Like, and also you quoted example of shock table test, sir. I seen this video when I was in my bachelor. It was shared by one of my teacher at from he was from CBRA Roorkee, and I seen its video. So it was just like recalling the memories. Thank you so much, sir. Thank you so much, sir. And now I would like to invite another eminent speaker, and he's going to present on retrofitting of RCC structures for earthquake safety. Nitin Verma, sir, is currently the AC&I, that is Aadhaar Consultancy and Infrastructure, Noida. He has 13 years of working experience in post-disaster recovery, including retrofitting of schools, houses, hospitals, constructing transient shelter all across the India. After getting trained as an architect, AC&I has been growing. After AC&I has been growing since the past 7 years and has been actively working toward the making existing buildings safe by means of repair and retrofitting. Before his association with AC&I, he had also worked at the post of senior manager at Seats for 5 years. Now, I would like to invite sir. Over to you, sir. Nitin, sir.
Yeah, can you hear me?
Yes, sir. Very well. I hear you very well, sir.
Thank you, Abdesh sir. Thank you, Amit sir, for giving me this opportunity. Can I want to share this, and yeah, okay. Can you hear me? And
sir, we can also view your presentation too on the screen, sir.
okay. I would just like to say a few words before I start my presentation.
Sure.
Both my senior panelists, Bose ma'am and Rajan bhai, are very senior to me, and they have been working. I mean, obviously, and they have got in-depth knowledge, and probably retrofitting as a subject is what probably they have evolved. Both of them. Rajan bhai, I know him, his work from Gujarat and details. Bose ma'am, from her experience in from the colleging, from basically the education part, and then now with DTF. I know they are doing very good jobs and very eminent people. I probably am not that experienced as compared to both of them, but I have a story to tell. I have a story, very different kind of a story. I mean, I've been like a student, a good student, popped out as an architect, not as an engineer. I'm not an engineer. I have to say this. Put that on record. And
one thing I would like to, sir, sorry to interrupt you, but one thing I would like to make here, one point that here the architecture department is also here in Invertis University, and many students has when they see your name, then they personally send me the message that we wanted to serve as a speaker because you are the architect.
I'm an architect. I'm an architect. And honestly, I'm an architect. But over the years, over the past 20 years, initially 12 years with the NGOs and UN system, and with under the guidance of Dr. Chandan Ghosh as well for good time. I mean, field of retrofitting, I've been the post-disaster recovery. So obviously, in 2012, to cut long story short, I mean, in 2012, I met a genius, a 70-year-old young man, Mr. S.B. Suri, who was at that time ex-chairman director. I mean, even he would be today, even ex-chairman director, CSMRS, who met me in Sikkim while I was doing the retrofitting for the Gangtok Governor House. In my personal capacity and as a company that I were trying to think. And he came up and said one line that he said, "तू सारी उम्र ये बात कहता है retrofitting होगा तो retrofitting होगा और retrofitting से ये हो जाएगा वो हो जाएगा, and why do you probably are only seen when there is a disaster strike? अगर काम करना है, अगर retrofitting करना है तो पहले करना." And honestly, those words were the sentences which were there for the change, which changed my life. I left all the jobs, came back to Delhi, and decided to start Aadhaar Consultancy and Infrastructure, a company dedicated to retrofitting. So today, I would only share the experiences that we have gathered in my journey in the past 8 years with ACI. I, being the managing partner, I take the lead. Other partner in the company is my mother, so you can call me as the wholesale thing. And my mother, obviously, for all the legal reasons and not for the any technical reasons as such. But we have a team of 28 engineers who work only for retrofitting. And in our journey for the past 8 years, we have been supported. We have been supported really well by all my seniors from the development sector, if I can call it so, including Rajan Bhai and many other people. My friends in UN system and my friends in WHO, my friends in World Bank, and then the engineering fraternity which I have been working with. I work with most of the structural engineers across the forum in Delhi, at least northern India. I work for many institutions presently. We have been involved in retrofitting a few embassies in Delhi, including Switzerland, Sweden, Germany, Brazil. We have seismically retrofitted them, analyzed them. Our friends from IIT have been involved with them. IIT Delhi, IIT Jammu, now Chandan sir himself, now IIT Roorkee, and we have gathered some experience. So what I'm trying to do is I've just put a small presentation here of few of the works that we have done from ACI. Hope you would enjoy. I'll move from here to the presentation. I will not go into any theoretical parts. I will only show you some images that we have done, and probably that may help you understand what we are trying to say. What my seniors, rather, both Bose ma'am and Rajan bhai were trying to say. So we are a cutting edge technology company that work for solution based repair and strengthening projects, and that is the only motto. This is what we work for. This is what we work for. This is 2015 Nepal earthquake. Rajan Bhai has been working in Nepal, but probably for the others. I work for RCC structures and probably like these. I mean, the kind of buildings that you see nowadays in Delhi, Gurgaon, Noida, all across. G plus 14, G plus 16, G plus 18 structures. And honestly, they are my client now. This is one particular image which moves me. We retrofitted this particular building. I'm forgetting the name of the project, but it's somewhere on the outskirts of the Kathmandu. And as you can see, it's entirely non-structural damage. Entirely non-structural. Very minimal structural damage was there. I would not go into details, but my reason to start with this image is that you have to realize that when an earthquake strikes, in a multi-story building, you are living on a flat, let's say on the 10th level or 14th level or 16th level. If a building is to face even the non-structural damage, imagine your plight. I have seen these houses from inside. I have seen buildings. I have seen where husband and wife and families were having a evening tea, and they left it. They had to run. Even the lifts collapsed. I mean, they had to run down 16 floors, 17 floors, and the chaos, and they have not returned to these buildings. Even today, after retrofitting, it is getting very difficult for the developer to call these families back to the high rise. The moving part, this is back from Sikkim. The buckling of the column. I am running now. This is a composite structure. If you can see the nature of the column and the brickwork and the things, damages. This again comes from Sikkim. This again comes from the shear off of the column. Look at this part, again from Sikkim. So this comes from Nepal. These are live images. If you can see the structural damage in the other building, if you can see the shear off of the beam over here. The hanging beams, the plight of the hanging beams and the base of the on the brickwork. So coming back, this is something which everyone would know. I would not go into engineering details and things. What is the procedure that we follow? It's the same as what Miss Bose ma'am and Rajan sir have been telling. It's the same part, and the procedure also is the same. You have to get the visual inspection, condition surveys. You have to get the drawings done, investigations on the soil, conducting these analysis on the stats and the ETABs, and designing the rehabilitation scheme. And this is exactly what we do, execute from our office. So, but you come to the, and when you're living in a Delhi, you're catering to a market like Delhi. North India, if I can call it so, Delhi, Gurgaon kind of thing. So you get to see that if an earthquake safety has to be implemented, if retrofitting has to be executed, the first thing is you have to identify the distress. I mean, at least from our perspective, we cannot question our fellow structural engineers. Obviously, we can't. They have designed building. There could be a change of the building codes. There could be a parameters up and down which might have been there. But we understand that these buildings have been designed for a certain level of structural safety. Now, the first problem that comes in between is the distress, which is easily neglected. No people moving into a high-rise building. You move into the basement and you talk around and you look around the building and you tell them, look, there is a crack, and they'll come back and tell you, "Oh, plaster में crack आया होगा." अरे वो कोई नहीं, वो थोड़ा सा कंक्रीट झड़ गया, मैं इसको थोड़ा सा रिपेयर करा दूंगा, मैं इसको प्लास्टर में ठीक करा देता हूँ. And then I have to tell them, sir, look at the kind of the crack that you're talking about. It's not about a plaster ka crack. There is corrosion. Crack is only a manifestation of the infection that's inside. You have to attend to that. अच्छा, हाँ देख लेंगे, ठीक है, ओके. हमने 4 कॉलम में हमने सरिया बहुत बढ़िया डाला है, हम बहुत अच्छा सरिया, इसकी बहुत बढ़िया कंस्ट्रक्शन है. सर ग्रेड ऑफ कंक्रीट, वो ग्रेड ऑफ कंक्रीट मुझे नहीं पता. So you account all the first point when retrofitting, obviously same as the other part. I mean, you have to identify your distress points. And distress, there are two common things. One is corrosion, another is seepage. Obviously you have to correct these distressed things. I mean, obviously, what you're seeing in these images is about the columns. The easiest way to correct that is about doing a jacket. Now, coming back to the design of retrofit here, the design of retrofit again is the most tricky part. So either you are designing to take care of the repair, which is more about repair and rehabilitation, or you are getting into the realms of by saying, I have to analyze this building for the design deficiency as well. And if the design deficiency is there, then those design deficiencies have to be taken care. And then whether the building provides for the codal provisions, which are the current one. I mean, not the codal provisions of when you constructed the building, probably in 1991, 1994. The codes were updated in 2005. So design of this retrofitting becomes the critical part. And that's where comes in the money. A client will only decide, यार आप इसको ठीक कर दो. Okay, sir. हम इसको ठीक कर देते हैं, but then you have to understand that we are talking about the repair and we are only trying to bring the building back to the original design stage. You are losing an opportunity to retrofit it to an extent where this building will cater to your requirements of the future. So this is the give and take which comes and goes with the client. And obviously retrofittings of these many buildings, we have done at least 8 or 9 structures now across Delhi in high rises. Dwarka is a particular location where most of these buildings happen. I mean, simply because it's a which came around in year 2000 or so, from the 1995 to 2000, 2004, where probably the worst quality of water was used in the construction, and they face. But then at the same time, it's also that kind of a people who are residing there who understand ki, what are we talking, but they still need to be about it. There's a difference in the term repair rehabilitation, and there is a difference in the term retrofitting. Retrofitting, what we refer to as retrofitting, is about strengthening. It's not bringing back to what was designed. Similarly, these are the finished things. Obviously, once you take care of that, it's the finished new thing, and once they see the finished product, they are very happy. And these things, obviously, not only to the high-rise buildings, we have done these exercises for the bridges as well. This one, I would not refer to the name of this one, but I'll show you the next slide, which all of you would easily recognize. This bridge I would not refer. This is in Delhi, obviously. This is in Delhi, and that was the original design. And this is what we delivered back to them afterwards. Sorry, I've missed an image somewhere. Okay. I have missed an image. That is Delhi Metro line, which we retrofitted last year. And ACI, I mean, for approval, I have to say ACI is the only agency that is now registered with the Delhi Metro for seismic for the retrofitting, not the word seismic retrofit, structural retrofitting of their lines. And there was a fire in the Delhi Metro line under the viaduct at Kalandi Kunj, which we sort of helped Delhi Metro assess, did the load test, did the live test, and designed the retrofitting along with the DMRC engineers, and finally handed it over them after executing. And that's how we work. I have lost that image. It's somewhere there. Now, this is another of that another high-rise building which we have done. This is a Novotel hotel, which was, I mean, boss ma'am referred that retro city, but also there is a change of plan and kind of things. So this was actually a 10-story building which needed to be upgraded to 14 floors after our FAR change and a new hotel came up and things, and we did the entire structural retrofitting for the same. Now, the same thing, vertical members, columns are the most important aspect, obviously, yes. But what about the local members, the beams? Same problem happens, and the corrosion and the kind of things, it again needs to be strengthened. So is the case with the entire grid. This is one of the developers building. It's on the outskirts of Delhi. It's in the Kundli area. Again, I will not take the name of the developer here. You can see the entire grid has been strengthened, but the strengthening of this scale is slightly complex because you have to take care of all the calculations. We have we have installed temporary structures to hold it together, because you can see there are these torsion cracks all across all these beams. So these torsion cracks will put together with the loads of the deficiency of the load and the deficiency of the design, entirely complex situation. This has been retrofitted again in the entire basement area of this thing. This is another developer. This time it's from Faridabad, where structure is absolutely fine. The columns are quite sturdy, and the beams, if you can look at, but main beam is not correctly designed. Main beam and the slab vibrates because of that. So this was again assessed and redesigned, and we inserted secondary beams in between. Obviously, when this developer approached us, and then the load has also, has been shifted from the main beam to the parallel beams outside. It's again a structural retrofitting on upper levels of the beam. Till now, what you were seeing was in the basements. Here you go on this. When you meet a structure where you find out that the shear reinforcement is inappropriate or deficient. So these kind of corrections can easily be done by a steel plating. Obviously, very easily done. At least by the time I have come into this business, at least people have got the sort of that inclination. आप एक बार testing NDT करके ये बताओ तो सही deficiency है कहाँ पे, ये cracks आ क्यों रहे हैं. This is another funny situation. You keep hearing in the newspapers, मेरे घर की छत गिर गई. रोड बेयरिंग स्ट्रक्चर है, वो छत गिर गई. अरे छत नहीं गिरी, कंक्रीट का कवर गिरा है, बिकॉज आपके छत के ऊपर पानी आ रहा है, रीइंफोर्समेंट में करोजन हो गया है, स्पॉलिंग हो गई है कंक्रीट की. बट देन यस, एट द राइट टाइम it is a dangerous situation. But imagine all these conditions where you have this beams, and they are on how I'm running my cursor. If you can see these cracks along the beams, cracks along the line of the reinforcement on both the direction. If you see on this left hand side of the screen, the crack on the outer side, the inner side, and this, and then the failure of the मेरे घर की छत गिर गई, आप आओ रिपेयर करो. And then I treatment and tell them कि आज ये स्टैटिक कंडीशन में ये कंडीशन है, अगर आप स्टैटिक मोड में अगर इस if I have to be standing at this point of the slab during an earthquake, how do you want me to respond? And then they come up and say, नहीं नहीं हमें तो सब कुछ चाहिए, आप आओ please आओ, you do the assessment. Driver for correction is not my agenda of telling them about the earthquake city. The driver, their requirement is because they have seen that the can be vulnerable to easy things like seepage के साथ भी इतना damage हो सकता है. Another room. Now there was this particular one came to me through Delhi police after there was a casualty when this collapsed, and there were a lot of people involved. After that, obviously the same. At times we get odd jobs where we have to enhance the beam sections. I mean, obviously for the requirement of the things. I mean, these are one of those odd jobs where we have हम concrete नहीं करने देंगे, हमारा घर नहीं गंदा होना चाहिए. ठीक है जी, okay, steel plate try करते हैं. Then you have got newer products coming in nowadays. All these companies that you see on the start of our slideshow, all the Sika, Fosroc, and all these big companies, they come up and say कि सर आप इतना काम करते हो, आप हमारे नया प्रोडक्ट है कार्बन लैमिनेट यूज करिए, ग्लास फाइबर रैप्स यूज करिए, and these have got this advantage, these have got those advantages. This is in one of the hospital buildings in Dwarka, where the beam sections were found to be inappropriate, and we have strengthened these beam sections entirely. I mean, very selective sort of repairs and retrofitting, where the carbon wrap has been used. And once this is done, obviously this is carbon laminate in the same project where you can see all these white grid lines where these structural engineers have lined out the cracks in the slab. And obviously these cracks appear for the deficiency of the reinforcement in the design. The easy fix, easy solution is the carbon laminate. You calculate the reinforcement efficiency, calculate the size of the laminate that you require, calculate the distancing in between this, and you can apply it very quickly. Quick fix with a 7 day sort of thing, and the building is back to normal. They can use it for their interior. Nothing stops. Nothing holds them for their development. Sorry, this image is what I was looking at that point. You can a lot of people can relate. So this is that region where the fire happened, where my cursor is moving, and you can see this column. Has been retrofitted up till the level. The capital of the column was fine, but onto the other column on this side, we jacketed the entire thing. We tested this entire viaduct with a live metro train. Did a load test for for the movement and the things. And with the load test, we found out the deficient part and the things. And this again, the carbon wrap has been done. I mean, it has been done in the history of the DMRC for the first time. And it took a lot of effort at my part as well to convince them. But now this all has been accepted and registered. Now it's an accepted practice in the DMRC. This is the back. I mean, I pasted that image on the wrong location. But when you see the fiber wraps over here, this is how these wraps can be made fireproof with a certain degree of plaster and concrete onto the top of it, and it's as good as a new building. So nothing wrong with it, and the people can move. They can use their building as they wish to. This one is from a fire affected building where only the outer structure got affected. So we just repaired it with a minimal thing. I mean, a shotcreting business from the inside outside, only to add a cover layer of a cover concrete, additional cover concrete. That's it. This one is not for a seismic safety, but it's more about the fire safety. I mean, the fire damage correction, rather, I should say. Now, coming back to seismic safety. Now, seismic safety And obviously, I said we get two kind of clients. One is who call us for the repairs of the distress, and then that's where when we have sit together and we have a good chat, and I can at least tell them about what is seismic safety and why should they be worried about, and why the when getting a repair being done, why do they have an opportunity to retrofit it for the seismicity. That's one set of people that we get. The other set of people are who demand seismic safety. This one is this one comes from Embassy of Switzerland. It was designed in Switzerland, sent to Delhi IIT. Professor Bishnoi, most of you might have heard about his name, and it came up with this, and the Swiss requirement was very simple. We have to have 18 shear walls inside the entire building, and these shear walls cannot be constructed on the existing foundations. So Bishnoi Sahab accepted the shear wall concept, but Bishnoi Sahab on the other side said that it is very difficult to construct it without using your existing foundations. We can upgrade your existing foundation, but to construct an existing foundation altogether would be very difficult. So Swiss engineers obviously didn't agree to it. They came up with the idea that we should do some micropiling inside the building. And honestly, at that point of time, Bishnoi Sahib told me later in a conversation after 2 years or so that we were the only people who said yes to that. And we did it. So inside the building, we did ground anchors or micropiles as they call them. Ground anchors into this, and the entire building ka foundation was constructed inside the building once again. And the Embassy of Switzerland is actually tied to the entire to the main ridge which is beneath it. Many of you might be aware of that these embassy area Chanakyapuri sits on the main Delhi ridge, which is the central, which is called as my geological friends would know, it's called as central ridge of Delhi. So this entire embassy is tied with 14 foundations tied to the entire ridge, and it is probably the most safe building because that's what the parameter was. So in the left hand side, you can see the ground anchors that we constructed inside. And on the right side, you see the foundations and how these foundations and the shear walls, the last, if I can show you, I mean, how these shear walls have been connected. Similarly, Embassy Sweden called us. They said, we have a heritage building, we have a residence of the ambassador, and the ambassador wants it to be absolutely safe. I mean, I'd say that there was a marked change in the behavior of these multinational agencies after Haiti earthquake hit. I mean, Rajan Bhai probably can explain that earthquake where the presidential palace, where the main UN hospital, their main police station, and their main hospital, all four buildings were completely shattered. So the first thing all these multinational agencies came up with that let's convert our buildings all across the spectrum and across the world, make them seismic proof. So similarly, Embassy Sweden came up to us and said, our building is absolutely fine. It's only ground floor story, but our ambassador's residence, which is a heritage property, it's a 100-year-old building. It's not safe. And again, Professor Bishnoi was hired from the thing. Vishnu साहब called me and said कि नितिन क्या करेगा? मैं कहा सर इसमें तो shear walls बनाते हैं back में. तो जब हमने when we started opening it and we realized कि probably इसके अंदर there was an acoustic double walling in between with minimal connections in between. And Vishnu साहब said, oh, you have hit the jackpot. Go ahead, open करो आप इसको and make a shear wall. So now this entire building is again seismicity proof back. Similarly came up later. I mean, I would not have those images here. An embassy of Germany came up at the time. I mean, embassy of Brazil came last. We did Brazil last year, which is again Aurangzeb Lane. Coming back to the other part, I mean, the housing societies, long housing societies. One of these societies, I could convince them and their cantilever buildings were probably converted. We tied them with support structures externally without disturbing their thing. I mean, it's very funny. At some point, I was maybe not the only person they were talking to, and they were talking to another structural engineer, or probably who he was. I would not know that. He came up with us said, "अरे नहीं, आपको अरे छज्जा तो बचाना है, छज्जा तो बचाना है, एक नीचे से कॉलम बना दो." So this people came up कि भाई वो तो DDA से रिक्वायरमेंट लेनी पड़ेगी, वो DDA से अप्रूवल आएगा अगर कॉलम आएगा। नहीं नहीं, हम करा देंगे, हम सब कुछ कर देंगे, एक नीचे से कॉलम बनाना आप कर दो। They came to me and I said, I am not an engineer, but by experience I know that if you prop a cantilever beam with a new thing, the behavior changes. So you can't prop them. There has to be some other way and kind of thing. We gave them our sample and we gave them our proposal, and then they got it verified from some other engineers and said, "Oh yes, you are right." Then we constructed this latest stage. This is another interesting project. I'll take the name. It's Unison School in Dehradun, where when you work in hills, entire hill region, the land is actually acclaimed. So they construct a shear wall initially, then fill it, and then the buildings are constructed on top of it. So similar is the case. This particular wall is a counterfeit wall. If you are aware of it, counterfeit wall. If I can easily say the words, then the buttresses of this wall happens to be the inside of the filling area, and the mud acts as the load which takes care of it. But this wall of this particular school collapsed for a distance of 180 meters, और उस 180 मीटर के पीछे, इस बिल्डिंग के पीछे 7 बिल्डिंग्स हैं जिसमें क्रैक आ गया. Obviously the earth moved. So we were called, there were all sort of things. People were worried and kind of thing. वो same stories को तोड़ के दोबारा बनाते हैं, and obviously rehabilitation तो पीछे वाली बिल्डिंग को सपोर्ट करना पड़ेगा and kind of. Being a retrofitting person, I came and said कि सर ये तो ठीक हो जाएगा. कैसे हो जाएगा सर? By now I was armed with my experience of the embassy of Switzerland. So the ground anchors is the solution. If the problem is with the buttresses and the counterpart, then the counterfort itself needs to be corrected and rather strengthened. We did some calculations with TPC, and we have done this entire ground anchoring for this entire wall for 180 meters, and now it's already, I think, 4 years or 5 years. It's all safe. It's a procedure with a 45-degree angle and all these anchoring was done. Overnight, obviously, it was school time and things, and we were asked to work in the night only. Then we moved on. We grew in confidence. Then we moved on. फिर हम कोई भी structure को save करने लग गए. We also went into post-tensioning and all those kind of things. This one is for one of the bridges where probably there was a soil slide and kind of things. We arrested that. You can see in the lower member, you can see these curved piles coming and kind of those things. Again, the smell of plastics, वो बीच में से टूट गया है, इसको ठीक है steel plates से support करते हैं kind of things. Now this is where we are now. At ACI in 2020, 2020 was a bad year for everyone, but ACI again gives me an opportunity to grow actually. Now this year we are trying to work for the retrofitting of the existing building with dampers. This is pure seismic stability. This is again in Delhi. It's probably the only project at this moment. Though there is, I've been told, at least I'm not involved with it, but I've been told that AIIMS Patna is being constructed with dampers. And it's already in advanced stage of construction, and there are many companies which are involved in it. But ACI has been approached by a very premium school in Delhi to retrofit their junior wing school with dampers. And so probably next time when we meet, we'll be able to show you some good images from that project as well. This is what keeps me going. It's the learning that comes from the field. Apart from that, there are repairs also that needs to be done. I mean, obviously, a lot of exercises that I showed you on the upper side were also about the strengthening, but minor repairs also have to be taken up. Epoxy injections, it's about the same project which you saw earlier. This, I would not have done this for the bridges as well. I mean, again, for the same bridge. And this is about the basements and the water tanks and kind of thing. This is demolition. This is that school which I am referring to. You can see we had to remove the part, and you can see how the entire school is constructed onto that, those things. Demolition part and the bridges, and this is now I'm getting into the domain of Rajan Bhai. I mean, I also did one of these projects, and I mean, I take at least pride in it, but only one of the project. So one thing which Rajan Bhai was trying to show you, if Rajan Bhai can connect and can see, I mean, we have converted these corners into columns and converted lintel bands onto the top and the gable and converted entire wall into shear walls at the same time. That's it. That's how I stand. And in the past, we have sort of worked for India. We have worked for IGNCA, which is Indira Gandhi National Center of Arts. We have done for MECON. We have worked for DMRC, for BMTPC. We have done for NHA, World Bank, WHO, Embassy Sweden, Switzerland, and so on. My biggest business comes from the corporates, which is Coca-Cola, Airtel, IMS, Springboard, Novotel, Coromandel Fertilizers, and real estate. That's how we stand. We have worked obviously in the northern part, but we are not averse to work anywhere. We have worked at Bihar, Vishakhapatnam, Nepal, anywhere. And that is what is our journey so far. That's all.
It's an excellent journey, Nitin Saab. It's so encouraging to listen to you, and there is no doubt that you have delivered a lot at national level, and you have revolutionized this profession of civil engineering or structural engineering into another profession, sub-stream retrofitting engineering. So, Madam Bose, you may raise a few questions to both the panelists, and then we may proceed for conclusion because we are already late. You have to unmute yourself, ma'am.
Yeah, it is an opportunity to listen to Mr. Nitin as well as Rajan Bhai. They have been in this field since many years, and I have seen many works of Rajan Bhai, not Nitin at present, but I know about him. He is working in this field, and he's a well-known figure in the world of retrofitting, and people know about him, and people refer to him when retrofitting is required. Now, my first question goes to Professor Rajan Desai, that we are following IS 13935, it's fine. But when it comes to the retrofitting and official retrofitting, they require calculations. Just follow it, nobody listens to that. They want, especially in the government, they want that with the analysis we have to show that these schemes will be okay. And many times those schemes are not okay also when you analyze. So how to resolve this problem? Because at present we are not having any code. So what is your comment about this? Analysis of the masonry building, which is a burning question in the field who are working in the retrofitting, that how to do the analysis of the masonry structure. Everybody is working in their own way. So what you would like to say about this?
That's a difficult question to ask. I mean, basically, whatever we have done has been based on IS 13935. With whatever constraints that the code poses, we have adhered to that. It doesn't allow retrofitting of more than with mud mortar and things like that. So, to what the guidelines have specified. And so I mean, then our approach has become that if we are not able to do any calculation, at least let us, if the concerned authority permits, then let's at least retrofit the way we can, because needless to say, that does add resilience to those structures. So this is the approach we have used, and some of this building that we retrofitted, it was done under Professor Arya's guidance. So where we had doubts, it was his guidance about what to do. Gave us confidence to go in and do what we were doing. And a lot of our retrofitting also has been on non-engineered and semi-engineered. And so, I mean, like, especially what I feel, and you talk of, the category E building, which are important buildings and all that. But on the other, what we find in Kashmir, where structures are demolished, there is no money to rebuild them for years, and children study in temporary structures. There we feel that even with the knowledge you have, at least you go in and do you do what the IS 1395 says. There will be significant improvement. So I fully agree, because of late we have been working very closely with Jitendra both now. And I don't know if you have heard of him. So I mean, he's like Professor Arya. I know that he's really high-five, very knowledgeable, but at the same time, his feet are on ground, and we are trying to pull him down to the ground, and he's trying to pull us up in the sky. So there is that tug of war between us, and he talks about code compliance, and we say that by talking about code compliance, you are making things so expensive. So this is another, because right now in Nepal for the last 2 years we've been working with this random rubble masonry buildings and retrofitting 2.5-story buildings using the containment enforcement system that we evolved with Professor Jagdish, and he has now upgraded what we had done, saying that this is a code compliance and otherwise the authorities will not permit. So he is right in a way,
You're right. Your guru and my guru are the same. So, in earthquake department, Mr. B.C. Mathur used to be there. I don't know whether you know him or not. He used to say the earthquake resistant construction is like when earthquake comes, it is, if you imagine yourself as if you are going under heavy rains. So if you put gumboots, you put raincoat, you put cap, you put umbrella, so you will be saved. But if at least you have umbrella, you will be able to save your head. So retrofitting is something like that. At least do something so you can save the lives. So you are absolutely right that for non-engineered construction who can't afford, who don't have the technical knowledge, these are the very practical solutions which are given in 13935. And if we follow it, that much can be guaranteed that in those houses, the damage will be minimum and deaths will be minimum. Definitely. I agree with you. And I really appreciate the excellent work your organization is doing. And it's really, I'm fortunate that I know you and I learn many things from you. Thank you very much.
Thank you. Thank you.
Okay, my question to Nitin is that you are doing wonderful works as far as the retrofitting is concerned. But a query is there that when you have to assess the strength of the existing structure, definitely we have to prepare the drawings, we have to go for NDT, and structural drawings are not there.
Yes, ma'am.
Now the main problem comes how to assess the foundation.
Exactly, ma'am.
So as far as the embassies are concerned, they have the money, they will vacate the building, they will go out, and you can just tear off that building and you can get every detail.
Yes, ma'am.
For an ordinary building where the hospital is running or school is running, how you will estimate that what is there under the ground? Or
Yes, ma'am.
what is there in the foundation? You can
Yes.
peel off, you can say dig the outer foundations only. So how you propose to assess that, which
Yes, ma'am.
will guide our students in a way how they
Yes.
should approve.
Sure, ma'am. Sure.
Thank you
Ma'am,
very
yes.
much.
Thank you, ma'am. Thank you. I mean, obviously, you're very right. That's the hidden part, which I often call as foundation as the black spot in the entire thing. You might get a knowledge about the existing reinforcement by all these bar locators, cover meters, and kind of thing. But foundation remains as a hidden part. So I'll take this as a part two of your question. To the part one, but most of the are never handled. I have to say this because if there's a group of seldom handed hands over the structural drawings to the RWA. So most that they are available are the architectural layouts. So many exercises gets delayed because we have to go back to the drawing board, get the designing done. We have to do extensive entity thing. Like even in the case of the Nepal, we had to do a project assessment, second in the designing, and third with the execution. And we said कि भाई client would not, well, obviously he said कि look, I am doomed. मेरी तो building टूट गई है. You come up to me with a plan by saying कि मेरे उसमें 4 करोड़ लगेगा, 5 करोड़ लगेगा और ये repair होके ये building ठीक हो जाएगा. I don't have that sort of money. You tell me step by step what do you want to do. So, sir, we need this drawing. Okay, we will help you with whatever is available. So the remaining, this foundation is not available, the reinforcement is not available. You have to generate it yourself. Yes, you are right. There are blind spots. Though in the superstructure, the blind spots can be sort of covered to an extent by getting the sizes of the members, by getting reinforcements into by cover meters and all these things by UPVs. The challenge comes in the foundation. Now, foundation may we have to go by experience mark. So yes, you are right. When you are dealing with a construction, when you are dealing with a construction, let's say post 2000, post 2000, यार यहाँ पे possible है either your raft connected footing piles इस area में नहीं होती है. So that is some basic information, basic experience that you have, and then you start excavating and verifying your hypothesis, if I have to say that in this case. The challenge is again when you go of Delhi and you, I mean, like a school that we are dealing with in Delhi, where they have got 7-year-old architectural layouts be available. They handed over as or a sketch bana sort of teachers use for their own purpose or coordinating. Their excavation becomes the only solution. But many things you seldom get exact footing. Part goes into the foundation beneath the things. So there again, some assumptions have to, and then you verify it by corner to corner to corner. Yes, I mean, yes, you are right. It's the most challenging part, but you have to deal with it in this. I mean, there's no short method to deal on the ground about these. You have to deal with it on a project to project basis.
That's true. That's true. Another thing you must be facing is the lack of the code for the analysis, especially when somebody asks for a higher performance level, continuous operation and this. So that is also a challenge which I also pointed out. Nitin will agree with it.
You say words, man. You're saying my words. The other thing, obviously, these softwares. I mean, Stat and ETABS and the versions and the difference of those. वो reinforcement में 19-20 में नहीं फर्क आता, reinforcement का difference double का होता है. So I mean, I can't tell you all these things. I mean, you know better than me, but it's a challenge in the. I mean, the business. We have to live with it and we have to cope with it.
Definitely, but we have to keep on doing this retrofitting. Only then we will be able to save the lives and save the structures.
So,
common man structure which Mr. Desai is doing. Thank you very much.
Can I make it? comment that I want to add. The problem about this design and calculations and all. See, basically, you don't have the design constants for most of these vernacular systems for masonry buildings. I think today what is required, I feel, is that the prime engineering institution need to take up the research on this subject. You know, the masonry structures are so much neglected in the education system that unless the prime engineering institutions get into this and start the research, you know, there is no way that one would be able to carry out the calculation that you are talking about. And as a result, if the authorities insist on that, that means that demolish the existing buildings or let them collapse into disaster and not do anything about them.
Okay, so Nitinji, the last closing words from your side, just to be as brief as possible, please, because we are already shooting time limit.
I would rather thank you, sir, for giving me an opportunity to present our.
No, thanks. Just your closing comments. Thanks.
No,
हम कर
thanks a
देंगे
lot.
अभी थोड़ी देर में.
No, very right. I mean, thanks for this opportunity. To post and things, but I would say that retrofitting is a business opportunity that people should also look at.
Okay,
so
good one.
So from the other, from business generation to actually executing it, I would say it's a business opportunity which should be looked at.
Okay, Rajan bhai, your closing remarks. You are mute.
Yes. We have to make saving of buildings a priority. If we don't, you know, then we will demolish buildings left and right, the buildings that don't need to be demolished. And especially today with limited resources and climate change and global warming, we have to go with options which are viable and which are, you know, which have smallest possible carbon footprint, because climate change is the biggest disaster, not the earthquake, not the cyclones, not the floods.
So Rajan bhai, propose a topic on which we can discuss on this, how to save buildings. It's very attractive and very encouraging to listen to you on this aspect, but it's definitely a challenge to save buildings. Madam Bose, please, you conclude not only your part, the concluding remarks and concluding remarks for the webinar. I'm not going to conclude now. So you just conclude and then we will go for formalities from Yogita.
Okay, thank you, Amir. I think it is an excellent effort by the Invertis University and NIDM jointly carried out, and because our budding students are listening to it, and for me that is the most important thing, because until unless we rather nurture them from there only, we will not be able to make it popular. Otherwise, we can count the people on fingers that these are the people who are working in the field of retrofitting. Until unless those students are motivated and they learn this subject will always remain a subject which is hardly dear to anyone. So I really appreciate your efforts, and I thank both the speakers. They have made the excellent presentations of their practical works, because students get motivated only after seeing, because they have seen now that this work is possible. So it will definitely motivate them, and teachers will also get motivated to guide them on this subject. And they will go and see these projects of Mr. Desai and Mr. Nitin, that how they are carrying out. And you can plan your tours also. So that way you can make this subject popular amongst the younger ones. So thank you very much for giving me an opportunity to speak in front of those young budding engineers. Thank you, Amir. Thank you, Avdesh. Thank you, Yogita.
And thank you to you, ma'am. And thank you to both the speakers for kindly agreeing for our invitation to be part of this series of webinars which NIDM is organizing. So thank you so much to everyone. So now formal closing to Yogita.
sir would like to say something before that.
Please, Avdesh.
In third Asian Ministerial Conference, our Honorable Prime Minister launched the agenda, 10-point agenda. And this webinar is basically focused on the item number 5, 8, and 9. And I think it's very well lost success in achieving the those points. And this is an extraordinary this extraordinary situation also provides us an opportunity to hear eminent speaker of our country that we have today. And we not only enlightened with the speaker, but they also quoted the incidences that they face in their life, and also quoted the example of their own gurus. So in indirect form, their gurus are also with us in this webinar. So with this, I would like to thanks NIDM and Dr. Amir sir for providing the opportunity to the Invertis University for this. And since concluding remarks is going to, so I'm not taking much time. Please, over to you, Yogita. Please come up.
Thank you, sir. Thank you, sir. I think you have said all the right words. As a formal vote of thanks, I'll be very quick. I would really like to express my gratitude towards all the eminent speakers. I think it is the speakers who make the sessions fruitful for participants as well as to the coordinators. So I would like to thank Dr. P.R. Bose ma'am, Dr. Rajendra Desai sir, and Nitin Verma sir for being the pillars of the program. Like the topic of the session is the retrofitting. So you bring the strength in our programs through your topics and through your knowledge and through your guidance, sir. So I welcome and I am very thankful for you to join with us through this program. I would also like to thank the patrons of the program, Dr. YVS Arya sir, who has graced this session and joined with us even after taking all the pains with the technical issues we are having. And I would also like to thank our Major General Manoj Kumar Bindal sir, our Executive Director NIDM, who have always been guided us through our journey through this webinar sessions, taking this into another level and providing a platform for our participants to connect with us and learn through these programs. I would also like to thank our program chairs, both chairs from NIDM as well as from Invertis, Dr. R.K. Shukla sir, Dean Invertis, and my guide, Dr. Amir Ali Khan sir, for teaming up together, bringing this program into the platform of in the form of a webinar and encouraging our participants for accepting to go for the right knowledge of safety and preparedness and showcasing the importance of retrofitting in the current scenario, obviously through our eminent speakers, obviously. So thank you for choosing the right set of speakers for giving us this opportunity as well. I would also like to congratulate Mr. Avdesh Kumar sir for coordinating this program nicely and for taking all the pains and before and during the sessions as well. And I also like to thank his team members for cooperating with us for this program. In the end, I would like to thank everyone and thank our participants for joining with us, even with all the technical glitches we had. So I would be thanking you for at least giving us the opportunity to bring forth this idea. And I hope you can take away some of the key points as eminent speakers have said. So I thank everyone for making this program a learning resource platform through joining with us. Thank you. Sir, you are muted.
I also join Yogita in extending warm greetings and thank from my side, from Institute side, to Mrs. Bose. No doubt she is the mentor of many of us, including me. Rajendra Bhai is doing national service, so is Nitin Saab is doing national service. So thank you so much to all the three eminent speakers. Thanks, great thanks to our Executive Director and Vice Chancellor sir of Invertis University. Executive Director NIDM is always kind enough to encourage us in taking up all these innovative thoughts to the public. So thank you, ED sir, for guiding us and allowing us to take all these things. Avdesh Saab, no words to explain your pains and your trouble, and making it so successful, coordinating nicely. To your entire team, your HOD, your Dean Saab, your Vice Chancellor Saab. So thank you so much. So with this, we just conclude here till for definitely for the participants who had patiently listened this program. So thank you to all who have participated, my NIDM team here, beyond Yogita and me, and beyond Avdesh and his team, for everyone. So thank you all who has been contributed to this program. So thank you. So thank you to the participants as well for sparing their time and energy and posing some questions as well. So thank you.
Thank you, sir.
Thank you, ma'am.
Thank you. I'm just ending, sir.
Thank you. Please end.